3. In this example, we've got quite a lot of information that we're talking about a point A, a point B. Later in the question, there's a point C as well. So there's quite a lot of information to take in and to think about. So we need to break it down into stages really carefully and make sure that we make a good note of what's going on in each stage. So we're talking about a particle that moves in a straight line from a point A to a point B, and it's got a constant deceleration. So that means that it's slowing down. So the acceleration will be minus 1.5. So if it's slowing down, remember to put a negative. The speed of the particle at A is 8, so that's our starting velocity, initial velocity. The speed of the particle at B is 2. And we're asked to find the time it takes for the particle to move from A to B. So the thing that we want to find is t. So looking at those quantities that we've got there, you've got to choose which equation would be the most appropriate. And I think VU, A and T, this would be the easiest one to use. We're told that the final velocity is 2, initial is 8, and then we've got minus 1.5 multiplied by T. Rearranging, bring the 8 over, we've got minus 6 equals minus 1.5 T. And so carrying out a division, we get that T is 4 seconds. So to move from A to B takes 4 seconds. Part B, we have to find the distance from A to B. So it's the same scenario, but this time we want to find distance. There's various formulae we could use. You could use S equals UT plus a half AT squared. Or you could use one that's, I think, a little bit simpler in this case. U plus V over 2 multiplied by T. So if we put the numbers in the correct places, we've got U is 8, V is 2, we're going to half it, and multiply by T, which we've just worked out. Sometimes I try and avoid using values I've just worked out in case I've got them wrong, but in this case I'm fairly confident that I've got that right. So if we work that out, that works out to be 20, and we're in standard units, so it's 20 metres. I should really have said here seconds, so I'll add that on. Okay, after reaching B, the particle continues to move on the straight line with constant deceleration, and the particle is at the point C 6 seconds after leaving A. So from A, the total time it takes is 6. We've still got the same deceleration of 1.5, and we still know that from the beginning, from A, because that's where this time was measured from, that was measured from A, we know the initial velocity was 8. We've got to now find the velocity of the particle at C. Well, C is our new finishing point. We'd previously gone from A to B, now we're going from A to C. So our new finishing point, our final velocity, is what we're after. Same again, look at the quantities. I would use V equals U plus AT. So V is 8 plus minus 1.5 times 6. And working that out, I think gives us an answer of minus 1. Okay, now what does minus 1 actually mean? Well, if you're moving along a line from A to C, which is what we were talking about then when we're doing the question, we've got a velocity of minus 1. What that means is that the particle has actually started moving back in the opposite direction. So it's actually moving back towards the point A. So a negative number means you're going in the opposite direction to where you were going initially. And you'll learn a little bit more about that when you do vectors. I've actually started drawing some vectors there to represent that situation. Last question, part D, asked us what is the distance from A to C? So probably use the same formula we did before. U plus V over 2 multiplied by T. Starting velocity 8. The finishing velocity was negative 1. Divide it by 2. And then the whole journey from A to C, if you remember, was 6 seconds. Working that out gives us an answer of, I think, 21. So that would be 21 metres in total.